Hello and welcome. Today we're going to be talking a little bit about conditional probability. This is probably one of the more difficult topics that students tend to face in both years 10 and year 11, and it primarily comes down to the fact that it tends to be quite unintuitive. What you think it should be in terms of the probability of an outcome of an experiment is often not the case, and you've often probably heard of conditional probability talked about in the context of something called the Monty Hall problem. So basically, the next couple of videos are going to give you a foundation so that you can understand why conditional probability exists and how it functions. But essentially, the idea behind it is it's talking about the probability that an event occurs given that another event has already happened. So it's conditioned on the previous event occurring. So something to note, we use a special type of notation, and it is this one. It's the probability of event A, given that B has already occurred, is written as that P of A uh, bar B. Basically, that just says probability of A given B. Now, something that I really want to go and point out to you is the fact that the order is important. I'll show you very shortly. Because if you go and calculate the probability of something occurring depending on the previous circumstances, that can impact the probability depending on what has occurred first, whether it's A or B. So I think we might jump into a fairly simple example. Now, this example I actually pulled from Eddie Wu's videos, and it's a really, really nice unpacking of what's happening and why something is so unintuitive. So below, you'll see that we're talking about two fair six-sided dice being rolled. So it's a multi-stage event. I've already drawn the dot diagram below to help you out to understand basically how this is going to work because it's a multi-stage event and it's got dice. Ideally, we want to use a dot diagram rather than a tree diagram just because it keeps things nice, easy to work with. Okay. Another thing that I'm going to talk about is the fact that the dice are the same color. Okay. Now, before I jump into the rest of this question, I'm actually going to encourage you to pause here and give it a little bit of a go before I talk to you about anything and see if you can find out what your answer to question B is based on perhaps a gut feeling before I go through this explanation. And then I want you to compare what you thought was going to happen um, based off of what I show you. Okay? So let's jump into it. We're going to have a little bit of a look at this first question. What's the probability that at least one six will occur? Using our dot diagram, if we're going to have at least one six occurring, that means we can be working in that column, okay, or in that row. In both the column and the row, at least one six occurs on either of the dice rolls. Now, we can also have two sixes occurring down here. Okay, that's fine. That's still at least one. We're not doing the complementary events formula here because one minus the probability of six not occurring is all of these dots up here. So that's actually more work for us. And that's one of the very few examples where that occurs. But if we're looking at question A, let's have a little bit of a look. So probability of at least 1, 6 is equal to, okay, going to calculate this, you'll notice that we have 11 total outcomes. Be very, very careful there. It's not 12 because we're counting this one twice. Okay, 11 total outcomes out of a total possible 36. Now, with everything that we've done so far leading up to this particular point, you probably would have gotten that answer right. It's part B where it becomes a little bit more tricky. So, in part B, it said it is known a six is rolled on one of the dice. What is the probability that two sixes have been rolled? Now, your gut feeling is probably to go down here and say, well, the probability of a double six, well, we have one outcome out of a total of possible 36. If you're imagining this experiment in your mind's eye, but in real life, perhaps, basically someone's rolled the first die and you can see that there is a six on it. They've kept the other die in their hand and is waiting to roll it for you. So you know that a six has already occurred, guaranteed, no matter what. So how that works now, when we go and have a little bit of a look, and I'll write this in terms of the notation. Okay, the probability of 6 given a 6 has already occurred can be written like this, the probability of 6 given 6. Now, here's how we unpack this, and this is why it's a little bit intuitive. If we know that a 6 has already occurred, okay, we have to operate inside of that vertical column and that horizontal row. We can't have a 1 and a 1. That means that we haven't had a 6 occur. We can't have a 4 and a 4 or a 4 and a 3. That can't possibly happen. We know by the fact that a 6 has already occurred, I can only be operating off of these particular outcomes. So I could have a 6 and a 2, or I could have a 3 and a 6. So we know that a 6 has occurred. Now, order here isn't too important because we've said that the dice are the same color, and that's what allows us to get around this. So, based off of this, that essentially means that we've restricted our sample space from 36 outcomes down to 11. And in those 11 outcomes, there's only one of them where we would end up with a 6 occurring on the second roll. Okay? So the probability that a 6 will be rolled, given that a 6 has already occurred, is 1 in 11, not 1 in 36. And that's quite unintuitive, which unfortunately forms the basis for much of conditional probability. But there's some useful techniques that we can go and use to help approach a logical answer. But the main thing that I want you to walk away with as we move through the rest of this particular set of examples is the fact that when we're doing conditional probability, we are essentially restricting the sample space to a set of given outcomes that have already occurred. So it reduces it from the overall sample space. Okay? All right, let's dive into a couple more examples in the next video. So in the next video, I'll explain how this works and visualize it with something called Venn diagrams, something that you're probably already very familiar with. Okay? All right, thanks very much.